Hi guys, welcome to Did You Know? My name is Benga Yelabola. So Did You Know is a series where I share on a regular basis hacks and tricks that could help increase your productivity as a data analyst, whether you're a beginner or you're an intermediate level or even a senior data analyst. Sometimes it's good to have a quick refresher of our level of understanding of ways to hack our productivity and to help us deliver excellently in the workplace. So on this series of Did You Know Monday, I would be sharing with you on a one out of two series, right? So there would be a second series that will follow up from next week, hopefully. So on this series would be a data exploration hacks that can help you as a data analyst get started really quickly with data exploration. I do understand and realize that as data analysts, sometimes we come back with so many, workloads, and you tend to have quite a few time versus the number of workloads on your table to be able to carry out data analysis on various projects. So it might be quite useful to have a way you can hack data exploration quickly, right, without you having to bother yourself around, doing so many other things with respect to your ETL process. So this is you trying to leverage the power in Python, right, to increase your productivity with respect to data exploration. So on today's episode of Did You Know, we're going to be covering data exploration exercise with NumPy on Python, right? So we'll be writing together Python. So yeah, in a number of times you might also want to shy away from, using or writing your Python for your data analytical projects. But it's important that as a data analyst, you must always work in a way that is analytical and in a way that would help increase your productivity on the job. So the first series of today's episode would be covering NumPy 101, right? So did you know that data exploration can increase your ability to uncover insights from data in about 10 times way than you're currently doing at the moment? So let's get into it. Right. So what is NumPy? Of course, NumPy comes with so many possibilities, right? Which you probably are not exploring, or which you probably are not finding out you could do more, right, with the limited opportunity or the limited access that you've got with using list. So NumPy has come with several more tons of opportunities and capabilities in terms of what you're able to do. So generally, for the first understanding, so NumPy is an homogeneous arrays, multi-dimensional arrays, in the sense that it gives you access to be able to work with different dimensions of lists, right? Or whether it's a dictionary or whether it's even a list, you could convert any of those sets into a NumPy array straight up, right? So one of the things that it gives you access to is the ability to be able to carry out a number of complex mathematical functions like your transform, your Fourier transform series, your linear algebra, or even matrices, right? With the fact that this comes really open source, so you don't have to buy it's a fully extended library within Python, right? It's an external library within Python that allows you to be able to, have possibility to work with various structures or various data sets in your Python. Yeah, so today, right, you know that there are quite a few challenges that you would face with working with lists in your programs as a Python user or as a general data user. Today, for instance, if you got a list of salary in different departments and you wanted to find out what is the sum, or let's even say what's the product of this different list of salary in different departments, that can pose some challenge without having you to circumvent or write some for loops to go around that. So one of such you would find out as you would see us using NumPy today in resolving that one of those challenges, right? So in NumPy, the array objects, of course, they're generally called ND array, which tends to mean, dimensional array, right? ND array in the sense that ND means nth time dimension array. So it could be one dimension, it could be two dimension, or several more dimensions as it were, which allows you to be able to work with several dimensional data sets, right, within your program. So another important thing, of course, that you would find NumPy useful over other set of data sets that you could call, perhaps your list, your dictionary, or your set, right, is the fact that so within the NumPy array memory allocation, the way your system, by system I mean your interpreter, your Python interpreter, the way it assigns memory to the data structure, it's quite unique than you would have in lists. So today, for instance, if you're trying to store into a NumPy, right, it's like several more times faster than you would store a typical list, right? And this is why the problem causing that kind of delay in speed, or the delay in memory allocation, or in accessing items or retrieving items from a list. The reason is because with your list, right, so list generally has an open list generally has different memory allocation, right, for different entities within the list, right? So there is a memory allocated to your size, which is the size of the object that is stored inside the list, right, inside the array. There is also the reference count, which is talking about the number of references where such will be utilized. There is a path that also stores the object type and object value, whereas in a typical NumPy array object, you only have one standard 32-bit by default bit size assigned to that particular object of a NumPy, right, which allows you to be able to store several information, right, continuously within the same loop of storage size or storage space allocated for your NumPy object, right? So that gives you so much benefit over your list, right? So without wasting further time, let's get into the lab. So to follow this lab, you would need typically about 3 things. You would need a Jupyter notebook, which I would recommend that you get this from the Anaconda free distribution. So if you go onto your Anaconda, just Google search Anaconda or download Anaconda. That allows you to be able to download Anaconda. In addition, comes with the Jupyter notebook, comes with so many other libraries that are pre-installed for you, right, for you to follow this tutorial. The second thing that we're going to need would be the NumPy itself, the NumPy library. We have to have that into our code. And then you need pandas and matplot library. So I will follow you. You just work with me as I follow through the process of getting that on your system, right? So what is important again is that just get your Jupyter notebook downloaded. Preferably, I would suggest that you just get Anaconda, right, onto your system. So let's get into the business of the day. So if I go on to my browser, right, and to meet the first requirement, which is the Jupyter notebook. So Jupyter notebook, by the way, it's an interesting data exploration notebook for every data analyst or data scientist, more importantly. So you will see a lot of times that data scientists get to use this for their data exploration project, but this can also be very useful, of course, to data analysts, right, who are very keen around data exploration, which is one of the reasons why we're doing this, okay? So go to your google.com and download Anaconda. So if you go to download Anaconda, preferably the first link that comes out, just head on to that. If you're on Windows or Mac, you can just choose your preferred operating system and download that and install. So once you install this on your PC, what you should have, once you've downloaded and installed Anaconda, what you should have is when you search for Anaconda, you should have first the Anaconda navigator, which your typical Anaconda navigator distribution would be your Jupyter notebook, your the hub itself, and then Python distributions within that got installed, right? While you're installing your Anaconda, as it were. So, but we're not going to be starting our Jupyter Notebook from there. We're going to be starting Jupyter Notebook from the Anaconda prompt. All right. So if you, as I said, open your search button and type Anaconda, you should get Anaconda prompt, right? Which is the primary requirement to get your Jupyter Notebook triggered or fired within your system. So I'm going to open that Anaconda, and this is what you have. All right, so I'll just zoom this in a bit and bring this here a little bit. So if I come here, right, and we do Jupyter Notebook, this will trigger the Jupyter Notebook, right? And would open preferably from your default browser. All right, so this opens your Jupyter workground. All right, or this typically shows the root directory where your Jupyter Notebook is installed on your PC. All right, so with that done, let's go on to open a new Jupyter file or Jupyter Notebook, which will be preferably on the default, the default Python distribution or interpreter that is installed on your PC. All right. Okay, so let's just go ahead to click on Python 3. So if I go ahead to click on Python 3, you would have a playing ground, right? Where you can perform your quick data exploration. Again, the exercise or this walkthrough today will help you to basically get you started with understanding NumPy arrays and how you can access or retrieve items, store items in a typical ND array, and how you can also retrieve data from your ND array. The series to come, or the second series which will follow this one, would be helping you to deep dive into data exploration. But it's important that you get to understand how you can, perform so quick or access certain quick functions or methods within NumPy. And that's the essence of doing this video. All right, so as we said, for you to start accessing NumPy, or before you can start consuming methods or functions within NumPy, you want to be able to import it first into your data workbook or into your Python playground. All right, so to do that, we're going to say import NumPy, and we're going to create an object of that NumPy. I'm going to call it .mp. So if I hit that, which is hold your shift and press enter your keyboard, or alternatively click on the cell while you're still in code mode and click run. All right, so once you run this, is the same as hitting your shift and enter key at the same time. All right, so now that we've imported NumPy into our code playground, so let's create some buckets of objects of arrays, and we will see how we can start accessing arrays from here. All right, so the first thing I want to do is typically we're going to just create a typical object. All right, so I'm going to call that object, I'm going to call it values, or we're going to call it items. All right, so let's call this items. And so for you to be able to pass data into a typical array, so let's say we have this list, items 30,000, we got 4,000, and then let's say 600, and lastly 7,000. Right, so this is the items series of items 1. We're going to create a similar items 2. All right, so I'm just going to copy this, I'm going to paste this here, and I'll call this items 2. So let's say these are a series of items, or in other words, these are a series of values that you store as a list. Mind you, this is a list, right? It's a typical Python list, because if you want to check again, you can just do items, right? But items underscore 1, and if I print this, as a type to check what is inside items 1. All right, you get to find out that this is a list, right? So we're creating a second items list, and we just modify the entries inside list. So let's look at from the position of capability of list that you currently have. So we have these two lists. As a matter of fact, I'm just going to increase this. I'm going to reduce this and change this to 5,000. All right, and then perhaps this could be 800. So we have that changed. Okay, so you know, we have two lists currently created. Of course, you know that if I do an items, right, underscore 1 plus items underscore 2, I get to have, you know, all of the entries populated into the current entry, right? So in other words, what is going on under the hood is that your items 1, right, which is currently what you have here, is just the items 2 is appended to items 1, which might typically not be what you're looking for. So in other words, I might be looking at getting the total sum of each of the values or positions of item 1. So if I want to say items 1 index 1 plus item 2 index 2, I should be able to do that with this, and that's one of the limitations that you have. Let's change this to multiplication, and then we'll see really what we're talking about. So here you have a problem, right? And the problem is that it says you can't multiply sequence by non-int or type list, which means multiplication is not allowed with sequence that is not an integer. Remember, list is not an integer, so it's a non-int, and that's why we have this limitation. So this is one of the challenges that we have with working with lists. All right, so let's go ahead to see how we can overcome that challenge with NumPy. So if I modify this, right, this first line of code, and convert this list, let's see how we can convert this list into a NumPy array. All right, so to do that, I'm just going to use the key or the object of the class NumPy, all right, NumPy dot, and I'll use array. So with these, we would be able, right, to convert a particular array or a particular list into an ND array. So if I hit the enter now, you will see that this class will change from list into an ND array type. So generally, the object of NumPy arrays are referred to as ND array. N simplifies nth dimension, right? ND means nth dimension array. So that class has now changed into an ND array. So I'm going to go ahead again to do the same with the second list. I'll convert the second list also into an array, a NumPy array, so that we will both have them, you know, in ND array. So let's go ahead to see how this works. Did you see that? So now we're able to perform that multiplication, right, which we rather not have been able to do if we had to use them as separate lists. All right, so this is saying this multiplied by this, and this multiplied by this gives you this, this multiplied by this gives you this, this multiplied by this gives you this, out of the box. All right, so that's pretty much straightforward, right, in terms of list. So let's go ahead to see how we can now begin to retrieve items or create items and populate items in an ND array type. So in doing that, one of the things you want to ensure that you do, right, typically is also understanding arrays. So we're going to call this understanding NumPy arrays. So let's see typically how that works. So the first thing we're going to do is to try and create an ND array, which is what we've just done. All right, so I'm just basically going to using this examples here, we're just going to be seeing what are the attributes. How do we understand NumPy arrays? How is a NumPy array typically stored in your interpreter? So by the way, if you're getting a prompt or an error that you're unable to import this, right? So what you can typically do is to open another distribution of, say, just open another anaconda distribution, right? I'm saying if you're using your Jupyter Notebook for the very first time and have not worked with NumPy before, you might get a prompt that there's an error or you're unable to access the NumPy. So what you can typically do is go onto your Jupyter, open your Anaconda prompt and do a pip install. So if I do a pip install NumPy, so this is how you can do or navigate issues with being able to download a certain external file or library in your Python. So if I do a pip install NumPy or the name of the module you're trying to access and hit enter, that allows you to be able to import that NumPy. So it's because I'm getting this because I fulfilled that requirement before. So I've installed that before in my system. So take note of that. Okay, so now we have we want to understand how values are stored, right? What are the various attributes of an ND array type? Okay, so the first we can try items underscore 1. We can do, for instance, ND dimension. All right, so we want to look at the dimension of this array. All right, so what is the dimension of so the first thing we want to understand is dimension of an ND array object. All right, so to do that, we just do the name of the array. All right, the NumPy array, which is in this case NumPy, because remember we've converted this list into a NumPy array. So if I do an items underscore 1.ndim, I'll get to know the number of dimension, right, of this array. And the number of dimension is just one dimension. And now what do we mean by one dimension? So generally, if this is stored as a flat single list file, it is seen by default as a single dimensional array type. Single means one row. Remember, this is just one row. So this is one dimension, right? Because I can only describe it by one row. Of course, you could have multiple columns, but it's still one row or one record, all right? So, and then if you also check for the shapes, you can also check for the shapes. Shape of a NumPy, all right? Another one, NumPy array, could be gotten with items. So if I do an items dot shape, I get to know the shape, all right? So in other words, this is talking about the number of elements that we have on the array, in the array type that I have. So we have got 1, 2, 3, 4. So this gives you the shape that we're looking for, right? And then if we want to look at the size, which again typically represent the total number of items that you have, regardless of the number of items. So if I do an items, so we do an items, we call this first number of item size, all right? Arrays, NumPy array size. NumPy array size can be gotten by using items, which is the name of the array dot size. So this gives you the same number of elements. Okay, so this is a single dimensional array. Let's now see how to work with a multi or a two-dimensional array, and then we'll do a three-dimensional array, and then we'll see how we can introduce matplot library into array. All right, so let's get into that. So to understand a two-dimensional array, so I'm going to basically just going to copy one of this and I'm going to paste this here. All right, and whenever you're trying to expand from a single dimensional array into several more dimensional, all right, in other words, you want to have multiple rows, multiple columns, what is important that you do first is to have an external bucket to keep all the arrays in there. Right, so to create an external bucket, this is the way that works. So if we have, I'm going to cut that first. So to create an external bucket, you create the external bucket like this. Bucket, this is the external bucket, and pass the other entries into the bucket. All right, so this becomes the first row. In other words, by row index, this becomes row 0. All right, and then let's pass the second sub bucket into this array. All right, so let's quickly modify this. If I have, this is 800 and I have say 5,000 and I've got 6,000, and lastly we have 2,000, could be salaries, right? So if we call this salaries, for instance, all right, so let's say this is a salary NumPy, which could typically be salaries from 2 different departments, so department 1 and then department 2. All right, so if we look at these, we now have 1, this is row 1, this is row 2. So by way of dimensions, this becomes a 2-dimensional array. And why is this 2? This is because we have inside the main bucket, I've got one sub bucket and second sub bucket. All right, in other words, this is the first row, this is the second row. So if I go on to then check the properties, as we were saying the other time, if we want to check the number of dimensions, we're going to say salary dot ndim. All right, so ndim being dimension, so that increases the dimension from what you had here, which was a single file, 1 dimension, into a 2-file structure. So I've got row 1, row 2. So that explains why this is 2 in terms of dimension. All right, so and then if you also go on to check in this instance the shape, you already know how to check shape. So if we do a salary dot shape, gives you 2 by 1. Remember, when we did an items dot underscore 1 dot shape, we got a 4, 1, and explain to us why you had this 4. This 4 is there because you have 4 entries inside items underscore 1. So this is 1, 2, 3, 4. That's 4 columns, 0 rows. So when it's a single dimensional array, the way it accesses that is by just the colon, comma, 0 rows. So it is 0 rows, and hence that why you have 4 signifying the number of columns, comma, 0 signifying the number of rows, which is 0 row, in other words, just 1 row. So because this is 1 row, so it is seen as row 0, of course, so which means you can access that, as it is. Okay, so now we have, this increased, in terms of shape. We have the salary dot shape gives us 2 by 4, 2 rows against 4 columns. And then if we do the salary again by, let's say salary by size, we have the total number of items inside salary will be 1, 2, 3, 4, 5, 6, 7, 8. So we get a 8 if we do this. All right, so this gives you an access to be able to understand what are the entries that you have inside, the items or inside the salary array, that as it were. Okay, so moving on, let's quickly see how to accessing items from NumPy. How do you access items from a NumPy? So the first thing we want to do again is we have about 3 arrays. So we're just going to be using, for the purpose of demonstration, we're going to be using items 1 and salary. All right, so you can replicate, of course, the same applies to either items underscore 2 and across all the NumPy arrays that you have here. So we're going to just basically start with accessing items from 1-dimensional array. 1-dimensional array. All right, another word, 1-dimensional, 1-ndim NumPy. So for a 1-dimensional array, so we've got an items, for instance, underscore 1. So how do I access, if the question, for instance, is access, or if the task is to access, let's look at what we have inside it. I'm just going to copy this. All right, so we're going to paste it here, and then as a comment, by the way, this is how to add comments, typically in Python. Of course, you know that. So accessing, let's say we want to access 600, right? So let's say we want to access 600 from a single dimensional array. It's simple because we know that there's just 1 row. So we only need to mention the position of the items with respect to colon. All right, so if I want to access 600, becomes 600, right, into brackets. So by row index, by colon index position, this is colon 0, colon 1, colon 2. So this becomes colon 2. All right, so and then if we hit enter, we have a value 600. Okay, so the same applies to negative index. So I could also access 600 by items into brackets. Negative indexing works also. So we have negative index, let's say by negative index position, right, becomes, this is index -1, -2. So this could give you also -2, right? So this is the same. And then of course, you know that if you also want to access by index position, you could do -1, -2, -3, -4. All right, this can be particularly useful where you're trying to understand which is the biggest, which is the smallest, and then you want to remove or deduct anything from them. All right, so moving on, let's see how we can use that process also to retrieve items from a two-dimensional array. All right, so for a two-dimensional array, we're just going to copy the salary that we have here, and we're going to paste that here as a comment, and then we're going to say, how do we access which one, right? Let's access 5,000.